Hi, it's Gadget UK here again, back for another Nintendo 64 power supply repair. It's a different power supply revision, this, as you will see. It's not the same as the ones we've looked at in the previous videos. A couple of different videos out on the other revision that's got the little sub-PCB comparator board on its side. Right, I'm going to plug this one in. We'll measure this one as well. I'll have to be careful handling it, just because those caps will have a little bit of charge. But if we, wedge it the same way, I'm kind of used to the knee measurement process here, just with that at the top, and then the ground is up here, and that's the supply, 0 volts, 0 volts, 3.3 volt rail, those two, and then down here, 12, 0 volts, so we've got no power again. Yeah, and the switch was on there, by the way. I want to say the switch, I mean the main socket switch. So let's see, are these going to come out any easier than the other two? And the answer is yes, actually, on this one. So just carefully try and prise the plastic parts, just making sure I've got it unplugged. Hang on, I'm making sure I haven't got it plugged in. Oh, I am got it plugged in. That's good then. Yeah, that was nearly a bad mistake. And it goes without saying, don't open things on your knee like this. This is just like a recipe for disaster. Imagine, as I'm trying to prise this open here, if it came open and the PCB sort of landed on my leg, you know, yeah, bad things. And similarly, imagine if it was plugged in while I was doing this as well. It's better to work on a bench. Yeah, this is not opening. There's some lip or something here on this side. Yeah, this is different. This is different. Because you can see the little regulator modules there. Is it going to be the same sort of problem there? I don't know. Yeah, look, we've got the little comparator board there. So this is different. Yeah, so we've got two fuses there on this one. And we've got a fuse down there, 1.6 amps. Just having a little look around. Yeah, I'm not seeing anything obvious on this one. You know what, I'm thinking this one might be a fuse thing actually. Let's check the mains fuse. Yeah, so pulling that out, 5 amp this time. Really should be 3 amp. Yeah, that fuse is okay. More likely to be this fuse, because 5 amps, it takes a lot longer to blow than 2 amps, and the one here, where is it? There, that's 2 amp. So let's check that. That's alright. We've got a fuse here. That's okay. And then a fuse here. On the 12 and 3.3 volt rails, those. So those are okay. So yeah, this is a different fault. It's doing the same thing though, isn't it? So I'm thinking something comparator related. Capacitors obviously could be a thing on this. Maybe one of them's leaking or something like that. So anyway, I'll inspect it. I'll report back in a minute. Yeah, and from that board, I removed the very first cap that I spotted here in the middle. Nothing wrong with it. There's no telltale signs, but because it's small, other than that one, I thought maybe it could be that cap. I did measure here on the output side to make sure there's no shorts on the 3.3 or the 12. Sorry, yeah, this Nintendo 64 is talking over me. But look at this, 15.4 ohms ESR. That is really high. 10 microfarad, 25 volts. So let's get a new one of those in, see if it starts up. Yeah, I'm thinking this is not going to be the issue, if I'm honest, but we've got to just rule it out, haven't we? So let's just try and press that cap into position. And I am just going to bend the legs just out marginally, just to help hold it there while I solder it. I'm not sure the N64's weren't right there. When it's sat on the Star Fox screen, you get this sound, which I don't think it's right. Could be a bad ROM, could be the EverDrive, could be a fault with my N64, I don't know. I may just compared some footage online of that game. Anyway, let's just cut those legs off. I'll just loosely reassemble this, put its power lead back on, it clips off and on there, as you can see. And just give it a try. I may completely recap this one if this works. I've switched the N64 off actually. So yeah, do inspect when you've replaced a component like that, just make sure you've not got any bridges anywhere, and we haven't. So let's get the cable back on. Yeah, so we're on NECAM again. Ground, I think, is the top left, isn't it? It's up there. And 3.3 is down there. Nope, still not working. So that hasn't fixed this one, I don't think. Of course, it could be the ESR of other caps on there. You know, if one's bad, what's to say the other ones aren't? Yeah, so I'm thinking the thermal fuse has gone on this actually. There are two, you know, you can see it there, it's like mounted on the top of the transistor there. Switching transistor with a bit of silicon, it's that grey silicon again. Anyway, the points are here I think. Yeah, it's those two. Now I just heated this with some solder. Marked 127 degrees. I actually suspect that got to 127 degrees at some point. Now it could have been because of that cap. You know, we had that cap problem. Transistor's alright. I'm not measuring any shorts or anything anywhere there. So I just think that fuse has gone. So I'm going to desolder it and get it off there. I'll see if I can get the part number off it. And we'll try, well, I don't know, test it. I mean, you think heating here now, if this is one of these resettable ones where when it gets to 127 degrees either opens or closes, you'd expect to change, because it's going to be 127 degrees with that. You know, we're at 4 degrees C on the iron here. The point is, it should change behaviour. And it isn't doing. And I thought these were resettable. Now, I could be wrong. Maybe it is just a thermal fuse. So in other words, it gets to 127 degrees, it blows, and that's it. I always thought these were normally closed and opened at 127 degrees. But again, those sorts of things vary between different applications, different devices, etc. More like a thermocouple, but then again, it is a thermal fuse, it's marked as TF on the board, so it kind of makes sense, doesn't it, that it would blow. So maybe that's all that's wrong with it, I don't know. Incredible hot, there we go, time trying to get that from that silicon there. Anyway, it's off. Let me just inspect it. I don't really see any damage to it or anything. Let's just test it off the board there. Yeah, you see it's open circuit. And this is the thing. Yeah, nothing, no resistance, no nothing. So that thermal fuse is gone. Now I think because of that, I would maybe, well, check these caps here. Take the transistor off and just measure it off the board. There are a few diodes and things around there, so it's worth checking those as well. You see things like this, you may think, well, how's that ever going to blow? But trust me, if this is left plugged in, switched on, under a desk somewhere, and then you get like heat wave, you know, hottest day of the year type stuff going on, trust me, things like that could just blow for no reason. We have found that one cap there. I've had all 3 of these caps off here. They're all fine. The ESR's fine on them. It was just that one, and it's right next to the heatsink. This is what usually happens with caps. So I'm not ruling out the fact that those could be part of the issue here. But anyway, in the first instance, we need to go find one of these. It's P125TAN, 250 volts, 2 amp. I mean, technically I could just replace it with a 2 amp fuse to test it. And yeah, it says TF thermal fuse, 127 degrees C. So that is the question, isn't it? You know, has it blown from temperature or has it blown from current? You know, there could be a short here somewhere. Right, so waiting for that fuse, I took off this capacitor here. Looks alright, smells alright, no signs of anything on the underside. But if I put this up to the tester here, and try this on a few different testers, but the Alice Peak is doing the same as all the others, just as monitoring. It just doesn't detect it at all. It's open circuit basically. Open circuit, low capacitance. So maybe that explains where the fuse went. Yeah, so thinking about this is going to smooth the AC that comes in from the bridge here, I think. You might actually be smoothing the switching though. Yeah, I'm honestly not sure. It's smoothing though, isn't it? And without that smoothing, you can have a very pretty sharp wave. Maybe that just caused something to draw too much current. The transistor measures alright, everything around there measures alright, so it's a 47 microfarad, 400 volts. I've got a 33 here. And technically that may work, but I wouldn't want to leave 33 in, so I've ordered some 47s of a bit of a no-name brand, 400 volts, 105 degrees C. But we'll try it with this, yeah, when the fuse arrives, unless the cap arrives first, in which case we'll put the right cap on. But I think that's the issue. I think because that cap is faulty, it's blown the fuse. It may be that the cap's shorted, blew the fuse, but then this is open circuit now as well. That might be what's happened. You'd think it'd blow that fuse, wouldn't you? So, I don't know. It's a bit odd. But I'm hoping it's just going to be a combination of the cap we replaced with this cap and the fuse. Maybe it'll spring to life. Right, so I've got the new fuses here, 2 amp, 127 degrees, 250 volt rated. Let's just test this first one. So, there we go, it's closed. There we go, we know it's supposed to be closed. Now, of course, because this is 127 degrees, if you solder this, you're going to get hotter than 127 degrees, and my iron set's at 400 degrees C at the moment. So what we're going to need to do is mount this in approximately the right place, and we're going to need to clamp something onto the legs here. Good God, those legs are so long. I'll tell you what, let's just trim them down. They are insanely long at the moment. So I'm going to have the ratings facing outwards here so we can see them. Or someone else can if they ever need to service this. There we go, so the fuse is going to be sort of like that there, yeah, but we need to solder it in such a way that we don't blow the thermal side of that fuse, don't we? Yeah, and this is going to be the tricky part, really, of how do you solder that on, have it in the right place here. I think the answer is just to move this resistor out of the way, and I'm going to clamp the leg like that, yeah, with the pliers and hold it in place, you know, so I'm actually gripping it really firmly to thermally, heat sink it. Yeah, so yeah, you can see. Yeah, so you can see I'm going to grip it like that, hold it in the right place, like that, and then solder the leg on this side. We've got a few of these, but you know what? We might go through a few of these. Yeah, trying to get it on there. Right, so I've got that leg gripping it there. Need to get some solder on here, like that. It's incredibly hard trying to hold this at the right place and heatsink it. This, of course, would be perhaps a bit easier if I removed the transistor. Let me just see, keeping that thing clamped on there. Let's just see. Yeah, that's not clamped it on. Good God, this is going to be hard. Let me just see if that still measures. Yeah, it does. There's different things you could do here. You could wrap some wire around that pin, wrap it round, wrap it round, wrap it round, but you need it to be pretty tight, because if it's not tight, then you're not going to heat sink very well. So I'll just try that again. I'm just going to use different pliers here just to try and heat sink it. Let me just inspect that. Yeah, I think I've done that. Yeah, so I've managed to get one soldered there. And of course we can just bend this into position slightly to get it in just the right place. Let me now try heat sinking the other leg. You need more hands than I've got. That's it, just holding that, holding that, holding that. Yeah, so you can see I've sort of mangly, is that a word? Yeah, mangly sort of assembled that. Let's just trim that leg down there. I'm not even going to reflow that with flux, I'm going to cut it off with its large solder point. Do the same thing with that one. Just inspect. Yeah, that's on there. And then what we need to do now is sort of just try and manipulate this a little bit with its bendy sort of shaped legs just to the front of that where it was before. And then perhaps just make sure these legs are not going to bend out and touch the transistor at any point. Yeah, that should do. So I'm going to be able to mount that on the front of that transistor there with a bit more silicon. The key here is, has the fuse gone from doing that? Hey, it still works. So, now I have ordered the correct size capacitor, 47 microfarad, but I'm going to go with the 33 here. And we'll just give this a try, I think. So the positive is towards the inside of the power supply here. I'm just curious to see, is this going to work? Let's just move that resistor back over there again. Yeah, and this is where I might put some heat shrink over that, because that could short on there if I'm not careful. And get the transistor, get the capacitor around the right way here. So, yeah, let's just give it a try. What do you think? Do you think this diffuser is going to blow again? I mean, I measured the transistor, I'm sure there's no shorts there, so the only thing I can think is the cap failed and the fuse blew just from maybe something in that circuit getting a bit stressed or hot. Maybe it was the cap that got hot and passed some heat there, or the transistor got hot because its DC was not smoothed. That's a possibility, isn't it? I'll trim that down. Yeah, so that's everything back in place. We've got a capacitor that's just temporary because it's 33 instead of 47. Technically it should work, I think. I don't think there's going to be an issue with that. And then the fuse there's alright, transistor's alright, and everything looks good. So I'm going to get it back into its case with the cable attached, and we'll see if that's doing anything. So we need to connect the mains lead first here, like that. And then we need to just get it back in here. You may be tempted to test something like this, exposed like this, trust me, don't. Put it back into a case, secure it somewhere safe. Because switch mode power supplies, when they go, you get quite large explosions of things. Semiconductors can explode, capacitors can explode, and yeah, you want to protect yourself, your eyes, your face, etc. And you just kind of want a controlled environment where you're able to switch the blooming thing off. Sharpish. It's pretty easy to get it in that side first, maybe. And in fact, that's the way it was assembled, I think. There we go. Now, note, these capacitors can hold charge. At this point here, everything's flat, but anyway, let's just get that back there. Get that back there. I'll make sure the switch is off. Right, I'm going to switch it on. 3, 2, 1. Well, I didn't hear a bang. Volts DC. Let's just put the meter there. I don't want this to fall off. If memory serves, I think ground is there, is it? Up. Hey, look at that. 3.3 volts, that's it. It's fixed, I think. 3.3, let's check the 12. Yeah, there we go. So that was the issue. The thermal fuse had gone, and we had one capacitor, the main, not one, the main smoothing cap there, had completely drained of all its electrolyte, I think, gone open circuit, and one smaller capacitor. So it's anybody's guess as to the exact sequence of events there, but that seems to be working. So as soon as the 47 microfarad cap arrives, I'll fit that in there, and I mean, I could give it a test at this point. I'm inclined now though just to clean up the board, get the screws in, leave it plugged in like this, not into the N64 for half an hour or so, just check back on the voltages and things. If that works, perhaps give it a go, because I think at 33 microfarad as opposed to 47 of the original, it will work. Yeah, you're just not getting quite as clean a level there, and of course that could just put a bit of stress on that switching transistor, so I wouldn't want to use it for a long period of time with a 33 microfarad. If we'd gone up in size, maybe to 68 or something, then I think it'd be a bit better. Yeah, so working fine. I'll wait for the new capacitor to arrive. Put these thermal fuses away. I've got 4 of those spare. They're always handy to have. Right, so the weird brand caps have arrived. 47 microfarad. Let's just compare one of these side by side. Yeah, that's going to fit. It's marginally bigger, isn't it, by a millimetre or something. But, yeah, 47 microfarad versus 33. So, let me know, would you risk leaving a 33 of a better brand on there? Or would you fit a 47 of a slightly questionable, let's say questionable, I don't know. Never heard of the brand. I mean, let's have a look at that. Oh, it's Chong. Oh, yeah. They weren't marked as Chong in the advert. If it said Chong, I think I would just leave that on. But anyway, you know, 47 versus 33. Yeah, there's quite a big percentage difference in size. And granted, all it's going to be doing is smoothing the high DC here. I say high DC, you know, the DC gets rectified, I think. Just so that that transistor doesn't have a hard time with some, you know, unpleasant shaped supply rail. I'm surprised it didn't take out the MOSFET, actually. I'm assuming it's a MOSFET, it might not be. The switching transistor is the point. So the ground is down towards the connector there, so yeah, I'll put that back in my components drawer. The key though is we know this is going to work because, well, we've tested it already with the 33 microfarad there, and it worked fine. Right, let me just trim those legs down. Need to get a little bit of silicon onto that fuse as well, the thermal fuse. It's so cold in here that those didn't spring back open there. It's like, well, I think it's the cold that's the issue. So I'll just reflow those just for good measure. And clean those solder points up with a cotton bud in a second. Now the thing is with this, these have got red marks on, those haven't. Sorry, the ones replaced haven't. So I'm not going to mark these, I'm just going to leave it like that, actually. And then it's probably obvious that perhaps those have been replaced. Certainly when you look at the solder points underneath, they don't look factory. Yeah, and I've got the white silicon here for doing bathrooms and showers and things like that. And I know what you're thinking. You're thinking, surely that can't be suitable, but trust me, it is. It's just silicon, I'm sure of it. Even though it's grey, I think the only thing might be its temperature rating or something. So I've pushed that flat onto the surface of that transistor there, and in fact maybe I should just pull it back out. We'll get a tiny little bit of silicon in the gap if I can, unless this is dried. There's a chance it's dried actually. Yeah, you know what silicon's like, you get this little bung on the end, don't you? I used this a few days ago. I'm trying to fix a leak in my car actually. Yeah, let's try that again. I'm just trying to get it in between the two. There we go, it's coming out. That'll do. Just a wee little bit like that. And then what we're going to do is just squeeze that back in place there. And that's more or less how it was mounted. I think there was a little bit on the front there like that, but yeah, and it kind of really needs pushing right into it. That's it, like that, with a bit of force. And as you do that, you bend the legs, and then of course as it sort of wobbles back the other way. So I don't know if you can see there, those are well sandwiched. It's flat on the top of the transistor with the silicon around it. The final thing I would do is just inspect with magnification and adjust the little legs of the fuse, just in case they're anywhere they shouldn't be really. And yeah, there's no chance of anything around there touching them. I'm not sure if silicon dries quicker with hot air, so I may just get a little bit of hot air, 100 degrees-ish, onto the surface of that silicon. It may just expedite the setting process, really, drying. Yeah, so I'll just circle those 2 solder points there. If this was your own power supply, or you were going to maybe sell this as refurbished, I won't do. I'll probably just sell these as working, then yeah, recap it, because there's not very many caps. But what I do know about this is the other capacitors on here that are back on, they've all been off and ESR tested and they're fine. There's no signs of leakage. They've got really good ESR and correct capacitance. So, what killed this one? Well, heat. It's probably going to get really hot around this area. That one's alright, surprisingly. The same with that one. It's right next to that heatsink. So, you know what? Something like that, move it away from the heatsink. It may just extend its life a little bit, but anyway, that's okay to go back together once we dry that silicon a little. Yeah, so hot air. About 150 degrees C. So I'm just going to heat around that there. Bear in mind, it's got a fuse size, isn't it? It's 137 degrees. So you know what? I'm not going to go crazy on that. I'm just going to put a little bit of hot air like that. Yeah, because at the end of the day, that fuse is rated 127 degrees. So. Yeah, fuse is okay. It's keyed, so you can't get that around the wrong way, the mains lead. Yeah, so the best way to do this is upside down this way, and that goes into the channel there. And then, yeah, try and get the mains lead grommet back in there. Remember, if you've had this just recently powered up, the capacitors can hold voltage, so that mains one we've just replaced, if we just powered this recently, it could be holding 337 volts-ish. So you get a pretty nasty belt. So yeah, you've been warned. And what can you do? Well, you could pull the lid off. You could, very carefully remove without touching any of the solder points. Find the capacitor points. So like on the capacitor we just replaced, it's here. And use some pliers or something and just touch the 2 points together. Be careful what you touch too, because if you short that high voltage to a nearby connection somewhere else, you could actually create another fault on the board. But that's typically the method. Some people use a screwdriver, a flat surface, and just try and join the 2 points together like that. The safest way is with a high power, low resistance resistor. But no one does that in the industry. Trust me, nobody generally does that. Because A, it takes too long. Well, that's it. A, it takes too long. It's like when you're trying to repair something like this that's worth. And this is the other thing here. You can buy modern replacements for an N64 power supply for £15. So you then got to question, what's the point in trying to repair something like this? Well, I much prefer this versus a new modern switch mode type PSU. We might pick up one of those in a future video, tear it down and have a look at how bad they are inside. But I would imagine for £15 from China, a replacement N64 power supply, I don't think it's going to be better than one of these. I actually think I would prefer an original one, either this model or the model you saw in the previous video, the other common model, any day of the week versus one of those cheap junk ones. So using the iFixit toolkit again here with the gain bit, and let's just get these screws back in. Yeah, so turn it the wrong way. Yeah, when you turn this the wrong way, try and find the channel, it doesn't clip. So yeah, you've just got to just turn it the right way. I would imagine it's pretty easy to cross thread these, and they're incredibly hard to get out when you've got a worn gain bit tip like I've got here. It's a bit worn, this one, I think. I could feel it slipping there a few times. Slipped again. There we go, it's gone back in. There we go. So back together, nice and secure. Let's measure the voltages, connect it up and give it a try. It's ground there, isn't it, I think? Yeah, there we go. 3.44. So, yeah, I didn't show this very clearly in the last video, but I've shown it on the other ones. The ground is that top left there, yeah, and it's actually marked on here. If you look at the plastic there and the light, you can actually see the voltage markings. But anyway, ground is the top left when we have it this way around, and then these two here are 3.3 volts. Yeah, be careful you don't bridge your probes when you're measuring those. 3.4 is about right with no load, and then the bottom one down here on the left side is the 12, which will always be about 11. See that? 10.9. That's about right. I've always seen them like that. It may go up a bit when there's a tiny bit of load, but nothing much gets used on that line. I mentioned in the previous video maybe the GPU uses it. I think maybe it does, but I think it's about the video and audio levels. You know, it might actually get used by the op amp, for example, for audio output. I don't know. It's very low current usage though. The 12 volts is like 0.1 of an amp or something. Yeah, it's marked on here. 3.3 volts, 2.7 amp, 12 volts, 0.8 amp. I think that's the fuses that are inside there, so it probably doesn't pull 0.8 of an amp. It's probably like 100 milliamps or something like that, 250, etc. Anyway, let's unplug my power supply from the 64 and get this one in and give it a try. That's it. And I guess this is one of the reasons these fail, because, you know, the power supply is enclosed there. There's no vents. You know, if you look at this, there's no air holes or anything for air to circulate. It's halfway into the N64. This is the sort of power supply that will fail if you just leave it plugged in all the time and forget to switch it off at the socket when you're not using it. Right, let's switch it on. And it's working. Woohoo! So, yeah, very pleased. Let's try a bit of Xeno Crisis. Yeah, this is a new game on the N64. I will get a video up any day now, just covering a quick review of this. But that power supply is fixed. I mean, that's great. It's like within the last, this video and the previous N64 video, which was last week, fixed 3 of these power supplies in no time at all, with very little cost really. And each one of those were picked up for, I don't know, £4 or £5 each. That's that shipped, which is, it's not bad. And yeah, I think I'd rather pay that and the cost of parts versus the cost of one of those junk ones, you know, the new ones, the modern ones. Yeah, older is better in my mind with these. Alright, let's hit reset, and I'll show you the other bit of amazing homebrew that Valve have cancelled, which is Portal First Slice. I'm so glad I managed to download this first slice before it got removed. I would hope that it open sources it and just let someone finish it. Technically, there's nothing illegal about writing some code, you know, that ports a version of the game with a patch to another platform, but because it used the libraries there from Nintendo, their own libraries, yeah, in terms of distribution, you can argue that it's using, you know, what's the word, licensed libraries that, you know, Nintendo own. There's no permission being granted to do that, but we're talking about a piece of homebrew where people are doing the patch work themselves. Yeah, you're patching it yourself on your version of the game with your version. Yeah, listen to that. That's incredible. Yeah, as I was saying, your version of the game. So you need an official copy of.
Hello, and again, welcome to the Aperture site.
Yeah, I just muted that a bit. The point I'm trying to make here is, in order to produce this N64 ROM, you need to use a patch against your version of Portal, the PC version, and then it produces the N64 cart. But it's using Nintendo libraries. If that patch process was changed a step further, so not only did you need the original version of Portal, but also another original N64 cart with the Nintendo libraries, technically, other than Valve giving permission to, well, not really giving permission, but saying, alright, do what you want with, you know, our code on the N64, I would imagine in a court of law there'd be a different issue there. You know, you're not selling it to make money. and every individual's having to own both the original set of libraries on an N64 cart and Portal. There's no, I don't know, there's no rules being broken there as far as I can see, but there probably is in terms of protecting your IPs. But we're talking about patching here. This is the thing, you can't stop people patching things themselves. So it's all about distribution. If something's not distributed with, let's put the sound back on. Yeah, if something's not distributed, there's no law being broken, is there? It's incredible. It is absolutely incredible. I would have paid money for this, either to Nintendo or Valve or whoever.
Proceed into the chamber lock after completing each
It really is
task.
incredible.
However, note the incandescent particle field across the exit. This aperture science material.
And in the 4X tray here, I haven't shown you that, it's actually a dust cover for an Anden Star stand, I think. And he said you could use it as a component tray thing. Anyway, yeah, so that's going to feature in a lot of videos. We've got the cap we just replaced, we've got the small, tiny little cap there, which, yeah, it was 10 microfarad, 25 volts, and that had gone high ESR. The cap had just gone open circuit, and the thermal fuse that should blown. Anyway, I do hope you found that interesting. If you'd like to support the channel, please see the Ko-fi and Patreon links down below. I will catch you in the next video.